Hi, I'm Joe Whitworth. I'll be talking about a project, Confidential Neural Computing. As generative AI models grow increasingly capable, new product experiences can be unlocked by incorporating user data. Some integrations may ephemerally process user data, akin to incognito sessions, with limited access to sensitive data the user provides in a restricted scope. Other integrations may ingest long term user context to build stateful, personalized experiences tailored to the user. Responsibly enabling private generative AI experiences requires appropriate data safeguards. In this diagram, we show components of a user running a mobile app which delegates a workload to be run on a cloud platform. Each computation and communication layer introduces risk to the user and their data. The app may contain vulnerable or malicious code, or it may fail to securely communicate with the cloud platform. On the cloud platform, threats can come from insiders, for instance, from privileged admins abusing their access, as well as from hackers exploiting vulnerabilities. The cloud platform may reuse the same hardware or host platform for other cloud platform users. Without sufficient isolation, data may be leaked to separate users or separate workloads. The Confidential Neurocomputing Project is an exploratory research effort to build an ML framework that enables generative AI training and inference in secure enclaves. Our framework targets trusted execution environments. It leverages confidential CPU and confidential accelerators. It's built for remote attestation. The code and the hardware running on the remote server are attested to the client via evidence signed by our hardware root of trust. It supports privacy via confidentiality and transparency. Confidential computing technologies secure code inside the T from being hijacked or data leaked to the broader system. CNC deploys transparent workloads to the Ts that are externally verifiable, built in open source to allow external auditing. CNC's ML infra deploys to trusted execution environments, hardware-based, secure, isolated areas within a device's processor that protect data in use, securing data during computation. CNC makes use of CPU and accelerator-based confidential computing. On CPU, CNC deploys to AMD SEV SMP and Intel TDX, both of which are supported by cloud providers like Google Cloud. For accelerators, CNC targets NVIDIA's H100 GPUs, which enable confidential compute mode, where data moving between the CPU and GPU is encrypted and decrypted on the fly to prevent snooping on the PCIe bus. In addition, CNC also targets Intel's AMX Advanced Matrix Extensions CPU-based acceleration. This diagram illustrates how some components work together to form inference. The T container is loaded into the confidential VM, and the service owner sends the model to the T container via an encrypted channel. The client requests attestation evidence from the remote machine. Once the evidence is verified, the client sends encrypted requests to the container over a secure channel. The requests are decrypted inside the T, fed to the model runtime, and encrypted responses are sent back to the client. The requests and responses are only visible to the client and inside the T, not in any intermediary layers running on the host machine or cloud platform. This diagram illustrates some of the components used for training. The service owner passes base model weights to the service via a secure channel. A differential privacy layer receives user data and directs data shards into multiple isolated T containers on multiple confidential VMs. Each T container trains separate slices of data and is attestable to clients. Differential privacy components aggregate and apply noise to model weight updates output by training T containers to enforce data privacy properties and prevent the model from leaking private individual user information. The service owner receives the aggregated noise model weight updates, learning from the user population while protecting individual user privacy. Thank you for your time. You may contact us for further discussion at productcncteam@google.com.